sa mga aral sa mundo. Tayo na. Tumutok na sa TV, mag-aral ng maigi to get the lessons easily. It's tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop time. We learn all things, it's very fine, masaya. Tutok na. Tayo na. Let's come and learn together, supporting one another. We love, we care, we share. It's tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop time. We learn all things, it's very fine, masaya. Tutok na. It's tangkop time. We learn all things, it's very fine, masaya. Tutok na. Tangkop time.
The Department of Education, Division of Tangub City, in partnership with the local government unit of Tangub, presents Ang Tangkub, Transforming Advancement in the New Normal, guiding K-12 learners under broadcast media and instructional program, crafted in response to the need of making education possible and accessible to students at the comfort of their homes. It covers the most essential competencies, thematically layered in drama plays which were originally written, directed, and performed by teachers to see to it that education is securely provided. This is Ang Tangkub.
Tayo na. together, supporting one another. We love, we care, we share. It's tangkuk time. We learn all things, it's very fine. Masaya, tutok na. It's tangkuk time. We learn all things, it's very fine. Masaya, tutok na. It's tangkuk time. We learn all things, it's very fine. Masaya, tutok na. It's tangkuk time. We learn all things, it's very fine. Masaya, tutok na. It's tangkuk time. We learn all things, it's very fine. Masaya, tutok na. Tangkuk time.
Hello and good day, grade 7 learners! Welcome to the brand new episode for 4th quarter of ang Tangku! TV-based instruction!
Today, we will use models to relate the tilt of the Earth to the length of daytime, the length of daytime to the amount of energy received, and the position of the Earth in its orbit to the height of the Sun in the sky. It is important for you to have knowledge about these concepts for you to understand the time difference among the countries in the planet Earth. This topic will also help in explaining why we experience different seasons of the year. At the end of the lesson, you will relate the tilt of the Earth to the length of daytime, the length of daytime to the amount of energy received, and the position of the Earth in its orbit to the height of the Sun in the sky using models. But before we proceed with our lesson for today, let us recall your knowledge about the solar system. The solar system is made up of the Sun and everything that orbits around it, including the planets, moons, asteroids, and comets. In your grade 6 lessons, you encountered the different planets and its characteristics in the solar system, namely Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Our home planet Earth is the third planet from the Sun, and the only planet known to have an atmosphere containing free oxygen, oceans of water on its surface, and of course, life. In today's lesson, we will explore more about Earth and derive some relationships such as the tilt of the Earth to the length of daytime, the length of daytime to the amount of energy received, and the position of the Earth in its orbit to the height of the Sun in the sky using models. Earth is constantly spinning like a top around its axis. This spinning is what we call rotation. A rotation is a circular movement of an object around a center of rotation. It rotates eastward in prograde motion. As viewed from the North Pole star Polaris, Earth turns counterclockwise. The effect of Earth's rotation is that we have a cycle of daylight and darkness, approximately every 24 hours. This is called a day. As Earth rotates, the side of Earth facing the Sun experiences daylight, and the opposite side, facing away from the Sun, experiences darkness or nighttime. While the Earth spins on its axis, it also revolves around the Sun. The path of the Earth moving around the Sun is called an orbit. The Earth's orbit is elliptical. This movement is called revolution. It takes 1 year or 365.25 days to complete a full revolution that revolves from west to east or in the counterclockwise direction. As the Earth revolves around the Sun, it is tilted 23.5 degrees relative to the plane of orbit around the Sun. Earth's northern axis points almost directly toward Polaris, the North Star. The fixed tilt means that during Earth's orbit around the Sun each year, different parts of Earth receive sunlight for different lengths of time. For example, in the month of June, the northern hemisphere tilts toward the Sun. This means that northern hemisphere is more exposed to sunlight, causing a longer length of daytime. On the other hand, when the northern half of the Earth is tilted toward the Sun, the southern hemisphere is tilted away. Thus, people in the southern hemisphere experience a shorter length of daytime. During this time, the northern part of the Earth receives more energy from the Sun as compared to the southern part of the Earth. 6 months later, during December, the opposite happens. The northern hemisphere is now tilted away from the Sun, thereby causing a shorter length in daytime and lesser energy from the Sun. Contrastingly, it is the southern hemisphere which receives a more direct heat from the Sun, since it is tilted towards it. Therefore, it has a longer daytime and receives a greater amount of energy. In general, due to the tilt of the Earth, the amount of daytime is different in every part of the Earth, depending on which side receives a more direct heat from the Sun. If the place experiences a longer daytime, it means that it receives more solar energy from the Sun due to a longer sun exposure. When the length of daytime and nighttime is not equal, it is described as solstice. However, equal length of daytime and nighttime also occurs. It is called as equinox, wherein the Earth's axis is not pointed towards the Sun, but is perpendicular to the incoming rays. In this case, both hemispheres receive equal amount of energy from the Sun. As Earth orbits the Sun, the position of its axis relative to the Sun changes. This results in a change in the observed height of our Sun above the horizon. For example, in June solstice, the northern hemisphere experiences summer or longer daytime. In summer, the Sun will be at its highest position above the horizon and will take the greatest amount of time to cross the sky. However, the southern part of the Earth experiences winter, wherein the Sun's path is the lowest above the horizon and will experience the shortest day of the year. During equinox, which could be spring or fall, it traces an intermediate path. It means all locations on Earth, regardless of latitude, experience 12 hours of daylight and 12 hours of darkness. This time, we will use this model to see the relationship between the tilt of the Earth to the length of daytime, the length of daytime to the amount of energy received, and the position of the Earth in its orbit to the height of the Sun in the sky. The first concept that we will derive is the relationship of the tilt of the Earth to the length of daytime. These are the things that you need to observe from the model for you to derive the relationship of the tilt of the Earth to the length of daytime. Number 1. On June 22, or summer solstice, the northern part of the Earth has a longer sun exposure, resulting to a longer daytime than the southern hemisphere. Number 2. On December 22, or winter solstice, the southern part of the Earth has a longer sun exposure, resulting to a longer daytime than the northern hemisphere. Number 3. On September 23 and March 21, both the northern and southern hemisphere receive equal light from the sun, resulting to equal length of daytime. Number 4. The places on Earth does not always receive equal light from the sun, since the Earth is tilted 23.5 degrees on its own axis. This results to an equal length of daytime to some places, depending on where the Earth is located relative to the sun. The next concept that we will derive is the relationship between the length of daytime to the amount of energy received. These are the things that you need to observe from the model for you to derive the relationship between the length of daytime to the amount of energy received. Number 1. On June 22, the northern part of the Earth has a longer daytime, resulting to a greater amount of energy received from the sun than the southern hemisphere. Number 2. On December 22, the southern part of the Earth has a longer daytime, resulting to a greater amount of energy received from the sun than the northern hemisphere. On September 23 and March 21, both the northern and southern hemisphere have equal length of daytime, resulting to equal amount of solar energy received. And number 4, the longer the length of daytime, the greater the amount of energy received. And number 5, the shorter the length of daytime, the lesser the amount of energy received. The last concept that we will derive is the relationship between the position of the Earth in its orbit to the height of the sun in the sky. These are the things that you need to observe from the model for you to derive the relationship between the position of the Earth in its orbit to the height of the sun in the sky. Number 1. On June 22, the position of the Earth in its orbit is oriented in a way that the northern hemisphere experiences summer or longer daytime. During this time, the height of the sun in the sky is at highest position in the northern hemisphere. On December 22, the position of the Earth in its orbit is oriented in a way that the northern hemisphere experiences winter or shorter daytime. During this time, the height of the sun in the sky is at lowest position in the northern hemisphere. Number 3. On September 23 and March 21, the position of the Earth in its orbit is oriented in a way that both the northern and southern hemisphere have equal length of daytime. Thus, the height of the sun in the sky is an intermediate point. Number 4. Therefore, the height of the sun in the sky depends on the location of the Earth in its orbit. The height of the sun in the sky is at highest point during summer and lowest on winter. That's it, grade 7 learners. I hope that you learned something today. Now, prepare yourself for you to answer the different activities.
Good luck and God bless learners. Please prepare, grade 8 students, for Science 8 is coming next. This has been Miss Bernalyn Carpio
And Miss Mary Chris Malalis,
your science teachers. Always remember to keep reading,
Keep watching,
and keep learning at home. Bye! Hello and good day, grade 8 learners.
Welcome to the brand new episode for fourth quarter of ang Tangkub
TV-based instruction.
Today, you will be able to classify organisms using the hierarchical taxonomic system. It is necessary to classify organisms because classifying organisms allows us to better understand and organize diversity or variation of organisms. It also aids in identifying the different kinds of organisms correctly. By this lesson, you will know and discover the precise name or species of an organism for future use. After the lesson, you will be able to classify organisms using the hierarchical taxonomic system. As mentioned in the previous lesson, diverse life forms thrive on Earth. About 5 million to 50 million species of organisms that exist. With this variety, classifying them correctly is very essential. In this episode, you will be able to classify organisms using the hierarchical taxonomic system. Taxonomy is a branch of science that deals with the process of classifying different living species. In here, from the largest to the smallest groups, the different groups are ranked. The large groups comprise many organisms with little similarities, while the small groups comprise few organisms having many similarities. This categorization would tell us organisms having more similarities would be closely related than those species or organisms having less similarities. The hierarchical classifications consist of the domain, kingdom, phylum, class, order, family, genus, and species. The largest category is the domain. Kingdom category follows, which is subdivided into various phyla, or singular phylum. A phylum comprises of different classes where each class has several orders, and an order consists of different families. Then, several genera, singular genus. And each genus contains the smallest group of various species. Let's have this example of hierarchical taxonomic system of classification of a dog. As shown in this figure, as you move over the taxonomic categories, the organism's characteristics become more specific, and in effect, the group becomes smaller. At present, scientists follow the three-domain system of classification, unlike before where there were only two groupings of organisms, the prokaryotes and eukaryotes. The prokaryotes, which were commonly known as microorganisms, tiny and unicellular, have been divided into two domains due to molecular differences. These are archaea and bacteria, making eukarya or eukaryotes the third domain. Bacteria and archaea are two domains made up of only single-cell organisms. They are the type of prokaryotic cells that has no cellular organelles or even nuclear membrane. Though archaea and bacteria are very similar, they are also very different, like the cell wall of bacteria contains peptidoglycan, while archaea cell walls do not contain peptidoglycan. Now we have the domain eukarya. Contains a huge variety of living organisms. Eukarya has organisms that are both unicellular or single-cell and multicellular. The cells in this domain are eukaryotic cells, which means they contain a nucleus, membrane-bound organelles like the mitochondrion. The kingdoms of these domains are eubacteria, archaebacteria, at times called kingdom Monera. For the domain eukarya, we have the kingdoms protists, fungi, plants, and animals. In summary, we have three domains: the bacteria, archaea, and eukarya. As mentioned earlier, as you go deeper to the taxonomic classification of organisms, the more it becomes specific. Let's have these mnemonics on the levels of taxonomy for you to remember them easily. Do kings play chess on fine-grained sand? From the sentence, we get the order, domain, kingdom, phylum, class, order, family, genus, and lastly, species. Let's have this example, the taxonomic classification of dogs. They belong to the domain Eukarya, kingdom Animalia, or in the animal kingdom, phylum Chordata because they have chordates, class Mammalia because they are mammals, order Carnivora because they are carnivorous animals, family Canidae, Latin word for dogs, genus Canis, and species Familiaris. These two last levels, the genus and species, are the binomial name or scientific name of dogs or any kind of organisms. Next, let's have the taxonomic classification of cats. Again, they belong to domain Eukarya, kingdom Animalia, phylum Chordata, class Mammalia, order Carnivora, family Felidae, genus Felis, and species Catus. Now we have plants, also belong to domain Eukarya, kingdom Plantae, phylum Tracheophyta, class Angiospermae, order Graminalis, family Graminae, genus Oryza, species Sativa. The scientific name is Oryza sativa. Lastly, we have humans. We belong to domain Eukarya, kingdom Animalia, phylum Chordata, class Mammalia, order Primate, family Hominidae, genus Homo, and species Sapien. And the scientific name for humans is Homo sapiens. Modeling of the skill, which is classifying organisms using the hierarchical taxonomic system. In order to classify organisms, we need to be familiar with the hierarchical taxonomic system. You can either have the triangle shape or the inverted triangle. For upright triangle shape, going up is from general to specific, while for inverted triangle shape, going up is from specific to general. It doesn't matter what pattern you are going to use as long as the components are in order, meaning it cannot be interchanged. Starting from general to specific, we have kingdom, phylum, class, order, family, genus, and species. Take note that singular and plural form for species is still species. Now that we know the factors for hierarchical taxonomic system, let's have the taxonomic classification for garlic. Belongs to kingdom Plantae, phylum Magnoliophyta, class Lilopsida, order Liliales, family Liliaceae, genus Allium. They have the same genus with onion, and then species Sativum. Fact trivia: the last two names of the organism is the binomial name or commonly known as scientific name. The first name is the genus written in italic, then capitalize the first letter. And the second name is the species, which is in lowercase, also written in italic. Scientific name for onion is Allium cepa, and for garlic is Allium sativum. This is how you are going to classify organisms using the hierarchical taxonomic system. This time, learners, let's have your activities by drill. We have drill 1, drill 2, and drill 3.
Good luck and God bless, learners! Please prepare grade 9 learners for Science 9 is coming next. This has been Miss Mary Chris Malalis and Miss Vernalane Carpio, your science teachers. Always remember to keep reading, Keep watching and keep learning at home. Bye!
Good day, grade 9 learners! Welcome to the brand new episode for the fourth quarter of Ang Tangkub. Let's learn science together with me as your learning buddy, Mrs. Lucy Q. Scala. In the last topic, we learned that there are two basic forms of mechanical energy, the potential energy and kinetic energy. Potential energy is defined as the energy associated with height or position, having a formula of potential energy is equivalent to mass times gravity times height. It increases as the height increases, as observed in the formula. While on the other hand, kinetic energy is associated with motion, having a formula of kinetic energy is equivalent to 1/2 times mass times velocity squared. It increases if the speed of the object increases and vice versa. The principle of the conservation of mechanical energy states that the total mechanical energy in a system remains constant as long as the only forces acting are conservative forces. This means that kinetic energy can become potential energy or vice versa, but energy cannot disappear. It is only converted from one form to another, like potential energy converted to kinetic or vice versa. For example, whenever we use a hammer to, let's say, hit a nail and drive it into the wall, we are simply applying some force on the nail with the help of the hammer, which is causing some work to be done. At rest, a hammer does not contain any kinetic energy but only some amount of potential energy. When we swing a hammer up to some distance from the nail before hitting it, kinetic energy comes into play, and the combination of kinetic energy and potential energy in the hammer, called mechanical energy, will cause the driving of the nail into the wall. Or we can say that the force applied by the hammer to do work on the nail is mechanical energy, which is the sum of potential and kinetic energy. Our today's competency for Science 9 is to construct a model to demonstrate that heat can do work. It is important to study this topic because heat is important in all aspects of life, especially plants and animals. Plant life relies on heat, among other things, to survive as well. Heat is a result of energy, which can be beneficial as well as dangerous. Understanding the properties of heat can help increase efficiency of heat or energy use, as well as increased understanding of things like weather changes and survival. The distinction between heat and work is important in the field of thermodynamics. The first law of thermodynamics states that heat and work both contribute to the total internal energy of a system,
But the second law of thermodynamics limits the amount of heat that can be turned into work. I hope you're all excited to learn this because at the end of the lesson, you are going to be evaluated through answering the guide questions in every activity, and you are going to construct a model which demonstrates heat can do work.
In your Science 8, you have learned the difference between heat and temperature. Heat is a form of energy due to the moving particles. On the other hand, temperature is the degree of hotness or coldness of an object. When heat is transferred, the energy becomes part of the total energy of the molecules of the object, and this is called internal energy. Substances do not contain heat. They contain internal energy. Does this glass of water have internal energy? How do you say so? Well, there is no apparent energy of the glass of water on a macroscopic scale. But when we view it in a microscopic level, there is internal energy. Internal energy of a substance is the sum of molecular kinetic energy due to the random motion of the molecules, the molecular potential energy, which is due to the forces that act between the atoms of a molecule and between the molecules, and other kinds of molecular energy. It is the energy stored in a system by the particles. Internal energy can increase due to heat transfer, like in friction. When two objects slide against each other, mechanical energy is transformed into thermal energy. The internal energy changes depending on whether heat is absorbed or released by a system, and if work is done by a system to the environment, or if the environment has done work to the system. Phase change is also a change in internal energy. If a solid is heated, there is an increase in internal energy. At some point, the solid can turn into liquid. This is called melting. If the liquid is continuously heated, there is still an increase in the internal energy. At some point, the liquid will turn to gas. This is called evaporation. Internal energy is an essential concept in the study of thermodynamics. Thermodynamics is the study of heat and temperature and their relation to energy and work. The change in internal energy of a system is evident in the first law of thermodynamics. First law of thermodynamics states that the change in the internal energy of a system is equal to the heat added to the system minus the work done by the system. This law may be expressed in this equation, wherein delta U equals change in internal energy. Q equals heat absorbed or released by the system. W equals work done by or to the system. Heat and work may be positive or negative, depending on various conditions. Q is positive when heat enters the system. Q is negative when heat leaves the system. On the other hand, work is positive if the system does work on the environment. Work is negative if the environment does work on the system. So how does heat do work? Work is considered as the energy transferred when an object moves due to applied force. Let's consider this illustration. heat is added to the system. Therefore, the system absorbs heat. In this case, heat or Q is positive. The absorption of heat causes the movement of particles to be faster, resulting to an expansion of the volume of gases. As a result, work is done by the expansion of gases to the piston, causing it to move upward. This is similar to this condition.
This time, let's try to demonstrate how heat can do work by performing this simple experiment. Note, this activity uses hot water, so please be careful. Activity title: Bottle Balloon Blow Up. Materials needed: balloon, 2 tubs or pans, empty bottle with narrow opening, ice water, hot water, about half and half boiling water, and hot tap water works great. Optional: thermometer. Procedure: stretch the balloon over the opening of the bottle. 2. Set up a cold water bath and a hot water bath by pouring several inches of ice water into one tub and several inches of hot water in the second tub. 3rd, fill both tubs and notice what they feel like. You can also use a thermometer to observe the differences between the 2 tubs. 4th, put the bottle in the hot water bath and push it down so the water rises around the sides of the bottle. See what happens. Repeat this procedure in the cold water bath. Troubleshooting. If nothing happens, try adjusting the temperature of the water by adding either more ice or more boiling water. Guide questions. What is inside of the bottle? Can the air escape? What happens to the air in the bottle when you put the bottle in hot or cold water? After experimenting a bit, how can you make the balloon blow up? Shrink. What can you predict will happen if we leave the bottle in the hot water for half an hour? Why? From the activity, when you stretch the balloon over the opening of the bottle, all of the air is trapped inside. Putting the bottle in hot water causes the air molecules inside to heat up and begin taking up more space. Thermal expansion, causing air to enter the balloon and inflate it. When you move the bottle into the cold water, the air molecules cool down and take up less space. Thermal contraction. It also showed that heat transfer can be used to do work. Another way around, when you do heavy work or do exercises, your body produces heat, which makes you perspire. Hope you learned something new today, learners. Now kindly get your activity sheet number 1 in Science 9. Drill 1. Direction. Encircle the letter of the correct answer. Drill 2. Collaborative learning. Directions. Perform the experiment entitled Thermal-Powered Flower. Observe what happens and answer the given questions. Evaluation. Directions. Draw a model of any device or something that applies the concept of heat doing work. A scoring rubric is given in your self-learning material for your reference. Learners, I hope you have an amazing experience with me as your learning buddy. Always remember that learning science is easy and exciting. Good luck and God bless, learners. Again, this is Mrs. Luchiku Scala, your science teacher for today. See you on our next episode only here at Ang Tangkub.
Good day, grade 10 learners. Welcome to the 5th episode for quarter 4 of Ang Tangkub. Let's learn science together with me as your learning buddy, Mrs. Janice Burgunia Tulba. Today's learning competency is apply the principles of conservation of mass to chemical reactions. This competency plays a vital role in the world of chemistry because a balanced equation obeys the law of conservation of mass. This is an important guiding principle in science. A balanced equation allows us to predict the amount of reactants needed and the amount of products formed. Like for example, if you are trying to decide how much fuel for a spaceship going to Mars. Chemical reactions are the most important types of events in the universe. It's through chemical reactions that plants grow, produce fruit, and become compost for new plants. It is because of chemical reactions that human beings and all other animals reproduce, digest, grow, heal, and think. At the end of this lesson, you will be able to apply the principles of conservation of mass to chemical reactions. This time, prepare your printed self-learning materials and pen as we are going to explore conservation of mass to chemical reactions. Try to watch this next video for the concept.
A physical change is a process in which certain substance experiences change in physical properties like shape, size or appearance, or state. There's no change in the internal structure or molecular composition of the substance. On the other hand, a chemical change develops a new formation of substance. Atoms of one or more substances combined and rearranged to form new substance. Let's have these examples. When paper is torn, is it a physical change or a chemical change? Are we getting a new substance from this? Or are the chemical properties changing? Not at all. In this case, the paper is torn into pieces. The paper is still paper, and this is an example of physical change. What about when paper is being burnt? Here, paper is converted to ash or smoke. New substances are formed. Hence, this is an example of chemical change. When water is converted to ice, in this case, only the state of the matter is changing, which is a physical property. Ice can be converted back to water too, when you apply heat on it. This is another example for physical change. How about during respiration? We inhale oxygen and after the respiration process, carbon dioxide or CO2 is exhaled. Obviously, a new substance is formed, and this is another example of chemical change. Whenever chemical change occurs, we can say that there is also chemical reaction. In this episode, you will be able to apply the principles of conservation of mass to chemical reactions. The law of conservation of mass states that a mass in isolated system is neither created nor destroyed by chemical reactions or physical transformations. According to the law of conservation of mass, the mass of the products in a chemical reaction must be equal to the mass of the reactants. In the process of chemical reaction, two substances react with each other to form new substances. To make it simpler, let's put it this way. A and B react together to form the products C and D. Again, substances A and B react with each other to form new substances C and D. This is a chemical equation. With this, we represent chemical reactions with symbols. There are two sides in this chemical equation. On the left, where substances react with each other, are called reactants. And on the right, which are the new substances, are called products. The arrow is the flow of the chemical reaction. For instance, if A and B reacted after heat was applied, it will be written like this. For example, hydrogen reacts with oxygen to give us water. As its chemical changed, it implies that a chemical reaction took place. From this, we can represent the chemical equation like this. Using symbols, we can write the equation as for hydrogen can be represented as H2, oxygen can be represented as O2, and water, as we all know, is H2O. But what have you observed in this equation? On the reactant side, there are two oxygen atoms, while on the right or product side, there is only one. Is this chemical equation correct? This time, let's find out and go deeper with our discussion balancing chemical equation. Hydrogen reacts with oxygen to form water. This chemical equation is unbalanced. As mentioned earlier, the number of oxygen atoms on the left is not equal to the oxygen atoms on the right. Now, let's go step by step to see how we can balance the equation. Draw a table like this. This row in the table tells us the number of atoms of oxygen on the reactant side is not equal to the product side. It's 2 on the left and 1 on the right. So let's try balancing the oxygen atom first. There is 1 oxygen atom on the right and 2 on the left. We write the coefficient 2 on the side of H2O and multiply with it. This is a partially balanced equation. As you can see, we have now 2 atoms of oxygen on the left and also on the right. The number of oxygen atoms on each side is balanced now. But what about hydrogen atoms? What happened when we multiply H2O with 2? The number of oxygen atoms were equal on each side, but the hydrogen is not. The number of hydrogen atoms on the right became 4, but the number of hydrogen atoms on the left is 2. We can multiply the hydrogen atom on the right with 2 to get this equation. Is this equation balanced now? Yes. We can use the table to check if the equation is balanced. This is how it looks like. Simply multiply the unbalanced elements or compound to appropriate coefficients to have a balanced or equal number of atoms in every element. When the number of atoms in each element is equal on both reactant and product side, it is the time that we have balanced chemical equation. Let's have another example. Let's balance this equation. Using this table, write elements in the first column, number of atoms in reactants in the second column, then number of atoms in products in the third column. The elements in the equation are iron or Fe, hydrogen or H, and oxygen or O. Now, count the number of atoms in each element for the reactants and products. As you can see, the number of atoms in iron and oxygen are not equal. In this case, we need to balance the number of atoms in oxygen first by writing coefficient 4 on the side of the H2O molecule. This means that you multiply each of the element in H2O by 4, and this resulted to equal number of atoms in oxygen on the reactants and products, but not on the element iron and hydrogen. Next, balance the number of atoms in hydrogen by writing coefficient 4 on the side of the element hydrogen in the product side, thus multiplying it by 4, and resulted to equal number of hydrogen atoms on the reactant and product side. Finally, balancing the number of atoms in iron. Multiply by 3 the atoms of iron by putting 3 on the side of the element in the reactant side. Notice that you now have equal number of atoms in the reactant and product side. You have equal number of iron or Fe, hydrogen or H, and oxygen or O, and this resulted to a balanced equation. This correct and balanced equation can be obtained by trial and error method or hit and trial method.
After watching the video, let's have the steps to balance chemical equations. Number 1. Write down your given equation. For this example, you will use this reaction occurs when propane is burned in the presence of oxygen to produce water and carbon dioxide. Number 2. Write down the number of atoms per element. Do this for each side of the equation. Look at the subscripts next to each atom to find the number of atoms in the equation. When writing it out, it's a good idea to connect it back to the original equation, knowing how each element appears. For example, you have 3 oxygen atoms on the right side, but the total results from addition. Left side, 3 carbon, 8 hydrogen, and 2 oxygen. At the right side, 1 carbon, 2 hydrogen, and 3 oxygen. Number 3. Save hydrogen and oxygen for last, as they are often on both sides. Hydrogen and oxygen are both common in molecules, so it's likely that you'll have them on both sides of your equation. It's best to balance them last. You'll need to recount your atoms before balancing the hydrogen and oxygen, as you'll likely need to use coefficients to balance the other atoms in the equation. Number 4. Start with single elements. If you have more than one element left to balance, select the element that appears in only a single molecule of reactants and in only a single molecule of products. This means that you will need to balance the carbon atoms first. Number 5. Use a coefficient to balance the single carbon atom. Add a coefficient to the single carbon atom on the right of the equation to balance it with the 3 carbon atoms on the left of the equation. The coefficient 3 in front of carbon on the right side indicates 3 carbon atoms, just as the subscript 3 on the left side indicates 3 carbon atoms. In a chemical equation, you can change coefficients, but you must never alter the subscripts. Number 6. Balance the hydrogen atoms next. Since you have balanced all atoms besides the hydrogen and oxygen, you can address the hydrogen atoms. You have 8 on the left side, so you'll need 8 on the right side. Use a coefficient to achieve this. On the right side, you now added a 4 as the coefficient because the subscript showed that you already had 2 hydrogen atoms. When you multiply the coefficient 4 times by the subscript 2, you end up with 8. The other 6 atoms of oxygen come from 3 carbon dioxide. 3 times 2 is equal to 6 atoms of oxygen plus the other 4, which is equal to 10. Number 7. Balance the oxygen atoms. Remember to account for the coefficients that you have used to balance out the other atoms. Because you've added coefficients to the molecules on the right side of the equation, the number of oxygen atoms has changed. You now have 4 oxygen atoms in the water molecules and 6 oxygen atoms in the carbon dioxide molecules. That makes a total of 10 oxygen atoms. Add a coefficient of 5 to the oxygen molecules on the left side of the equation. You now have 10 oxygen atoms on each side. The equation is already balanced then. Note: coefficients are the numbers in front of the formulas. Subscript is a character, usually a letter or number, that's printed slightly below and to the side of another character. Do not change the subscript, only the coefficient. Another examples are now that you witness how to apply the principles of conservation of mass to chemical reactions, let us proceed to our drill. Are you ready? Let's start. Here's the directions. Balance the equation by completing the table with correct information. Please be guided by the given example. I will give you 3 minutes and your timer starts now. Are you done, learners? This time, since you already applied the principles of conservation of mass to chemical reactions, it is time for you to answer our activity with a partner. Directions: balance the chemical equations. Write the correct coefficient on the space provided before the chemical formula.